Hello class, this is Dr. Marshall, and today I'm going to go over kind of what we're going to be going and doing the next part of this unit. And so hopefully you understood the review material over the triangles, and we'll talk about that when I get back. So I'm just going to get right into talking about these three transformations. A lot of this could be review from middle school, so I'm not going to take too much time to go through that. If you'll remember, there's three main transformations where you take what we would call the pre-image and do something to that figure to move it. And that new figure is called the image. So any transformation in general can change things like position, where it's located, its size, or even its shape. And so what we're going to focus on right now are ones that will change the position um, but not necessarily change the size or the shape. Okay, so if you look at those, there's lots of ways of saying that. It could be a congruence transformation. It could be called rigid transformation because the shape isn't stretched in any way. It stays rigid or um, congruent to itself. Sometimes it's called an isometry. Right? All of those words basically mean the same thing. So again, the position can differ, but the two figures remain congruent, meaning that they have the same size and same shape. And so in middle school, sometimes you may have heard the first one described as a flip, so that's a reflection. And the key thing about that is it flips over a line. Each point on the pre-image, say point A, uh, is reflected over to a point on the other side, point F, and it's in exactly the opposite side and the same distance away from the line. So these that were further away are the same distance away from the line. Point C, which is closer, reflects to point H, which is just the same distance from the other side. And point B reflects to point G. And if you'll notice down below, A and F, there are the 2 points that are paired up, the pre-image and the image. And then you have C and H are listed third, and then you also have B and G, which are listed. And so when you list them, they are going to be in what we'd call a corresponding order. This little arrow means transforms. And so we'll use that regardless of which of the three we're talking about. So in a transformation, the main thing to identify is what's the line it's reflecting over. The second one would be a translation. And so when we look at a translation, that's like a slide. Those are probably the easiest to recognize because the figure looks exactly the same. If I would look at J to K to L to J, if I'm going to do a translation of that, what's going to happen is I'm just going to slide that figure in some direction. And here I would end at P, M, and Q. All right, so JKL is the original. And the only thing that you're going to describe here is somehow you're going to describe the direction that it's moving and how far are you sliding it. And then the last one is the rotation or a turn. So in a rotation, when you're turning, there's several things to describe, but basically there's a point at which you're turning around. So right here, this point would be called the center of rotation. Then you have an angle of rotation from here, right? And I can't quite get that angle to show up the right way, but if you look at that angle, that could be in some number of degrees and also direction. So it could be a certain number of degrees and clockwise or counterclockwise. All right, so what we're going to do is let's look down at these and let's just take a second. I want you to pause the video and look at each figure and to write down if you think it is a reflection, a translation, or rotation. All right, now if you have paused it, hopefully you have a reflection, rotation, or translation written above each one of these. And so what we're going to point out is each one. So this first one is a reflection. You might be able to see that, for example, this point, it reflects to here, this point reflects to here, and this point reflects to here. All right, next, let's look at the next one. That's going to be a rotation. So here we have this point is turning to there, this point to here, this point to here. They're all rotating around, looks like, the origin, the center point right there, rotating around. And the last one is going to be a translation. Now there's a couple things. How would we describe these? Okay, over what? Right? We need to be able to describe what is it reflecting over. In the rotation, right? We said it was around the origin, but how much? Okay, so we need to be able to give the degrees. And then the last one, translation, we want to be able to say how far and what direction. Okay, so let's turn it over and look at some examples of how we could do that. Okay, here's another chance to practice. So look at your notes and try and describe these as reflection, translation, or rotation. And I'll give you a chance to pause it right now. All right, let's go and talk about what they are. So if we're going from A to D, notice that when we talk about A, we're talking about this one. And when we talk about D, we're talking about over here. And what I notice is that they are really being moved. All the points are moving, just sliding over the same direction. So this is going to be a translation. All right. Then when we go from C to D, okay, let's see what's happening there. With C to D, what's happening is we're moving from here, and then we're going to here. And notice that they're not facing the same direction. And so what I'm kind of going to do is I'm going to kind of count 1, 2, 3, 4, 5, kind of 6 spaces or 6 units between the two. And it looks like they are a reflection. Okay. Looks like if I go 1, 2, 3 to right here in the middle, there's a line that it is reflecting over. So this is going to be a reflection. And notice that each time the shape is staying the same size and shape. From next of all, we're going to go from B to C. All right, B to C. And you can probably guess that if we've done a translation and a reflection, this is going to be, right? We're going from B to C down here. This is going to be a rotation. And so this is rotating clockwise. And we'll talk about the degrees in just a second. And then last of all, D to A. And notice that this is a reversal, right? Now we're going from D back to A. And so the same thing that happened up here in the original one, we're just going to translate back to wherever we started. So originally, we went from A down to D, okay? Now we're going to be going from D back to A, okay? All right, and our last example is from A to C. So again, A is up here, and we're trying to get to C. It's just over here. All right, now what's going to happen is, let me just show you, if I start with A and I translate it, if I just translate it right down here, you'll notice that it's not facing the right direction, okay? If I have it up here and I reflect it, so I'm going to flip it from left to right. If I reflect it over that side, it's not in the right spot. I mean, it's facing the right way, but it is not in the right spot. And so what's going to happen is I'm going to do a combination, or what's called a composition. So if you look in your notes right here, composition just means it's requiring you to perform a transformation of more than one transformation together. So one thing you could do is you could take this original one. Let's go back to how we started. I could take the original and I could translate it down. Ready? 1, 2, 3, 4, 5, 6, 7. And I could translate it over 1, 2. Okay? If I translate, and usually we do the X first, so I go 1, 2 to the right, and then down 7. Then the last thing I would need to do would be to flip it or reflect it, but over that same line. So it ends up right here on top of that point. All right, so that would be both a translation and a reflection. And those two together would make what we would call a composition. All right, let's look at a little bit more detail. All right, now we're going to just look at these in a little bit more detail. So notice that we're saying right here, we're going to inspect number 5 that we just looked at. And here's the question: what line is their line of reflection for this example? And so let's go back up here to number 5. And it says from C to D. So I'm going to kind of get rid of everything up here. And if you remember, we kind of counted 1, 2, 3, 4, 5, 6. And so it's halfway in between there would be 3 units. So I kind of went back, 1, 2, 3. And that was my line it looked like that it was reflecting over. If I draw a line right here, that is the line it reflects over. And so you can see that each point on the pre-image would reflect over that line. So what is the equation of that line? Well, because it's a vertical line, it would be x equals, if you remember from the last unit, all of our vertical lines are x equals, and I'm starting at, again, 0, then -1, then -2. So I would say it is a reflection over x equals -2. So that's how we could describe it. And we could go back up here, reflection over x equals -2. So that gives us the detail that we're trying to get to. Then we've got the translation. And so let's look at the translation. We're going to inspect number 4. Okay, so come on down here. Now we're going to inspect number 4. Come back, we'll get rid of this. And when I look at number 4, if you kind of follow along that explanation here, look at the upper left corner of figure A, -4, right? -4, +5, right? If that is our starting point, and then we could look at the image. So here we're looking at this point, -4, 5. And then if we change and look down here at the other point, where does that end up if I go from the pre-image down to its image and give those coordinates? Those coordinates are at -8, -2. That's my coordinates right there. And so what's happening is that this is moving 1, 2, 3, 4 to the left, or -4, and then 1, 2, 3, 4, 5, 6, 7 units down, or -7. So those two sets of coordinates are where we get, if I were to look at these two things, what's the x and what's the y? Again, not slope. I'm looking at what is the x change and how's the y change. It's a vector. We would call that right here, we would give the translation vector. That's what we're talking about. Anytime you do a translation, you can describe it in this particular way. Okay, right here, -4, -7. That's how the triangle, every point in the triangle is going to move back 4 and down 7. Okay. All right, I want you to take a second and answer this question before we move on. So how would you describe the translation vector in number 7? And if you go back up here, number 7 was going from D back to A. So take a second and do that. Pause it. I'm going to stop for about 5 seconds to give you a chance to think about it. And then when you think you have an answer, then I want you to unpause it and see. All right, so let's see what we got. Now notice we're going from D back to A. So if I start here at this corner and go back up to its corresponding corner, notice I'm traveling the same distance but in the opposite direction. So when I think about that, I'd be going 1, 2, 3, positive 4, and 1, 2, 3, 4, 5, 6, 7, positive 7. And so my vector would be positive 4, positive 7. All right, we're on our last two examples, so I'm going to get you started and let's see how you do. We're going to graph each image, and we're going to label our points very specifically. When we draw a new point, label the vertices of each image as P, and it has this little apostrophe, and Q in this apostrophe. So what we do is we read that as P prime. It's the first image, the prime image. So P is the original, and then prime would be the first image. And if you were to do a second image, we'd put two apostrophes up there, P double prime and triple prime. Every time you transform it, it's going to become a new image. So over here, we got PQR is supposed to translate 2, negative 2. So just a quick start, if I start at any point like point R, I'm going to go 2 to the right, so 1, 2, and then down 2, 1, 2. I'm going to end right here, and that's going to be R prime. Not 2, but just 1 prime. So take a second, try and do Q prime, P prime, and then connect them. Okay, so I've gone ahead and I've plotted out where each of my images should be. So I've got R prime here, I've got Q prime and P prime. Each one is over 2 and down 2. And if you'll notice, if I take my original figure and I move it 1, 2 to the right and 1, 2 down, that's where I end up, and I have the exact same shape in a different location. All right, I want you to try and do the same thing over here on this next example where you're moving it over 3 and up 1. I'm not going to get you started, you do the whole thing. All right, so I've moved each point over 3 and up 1, and now I need to connect them. Make sure you pause it right here and get the same points in the same figure. All right, here we are. So we've done transformations. We got one more to try. We're going to try and reflect. So look at the very last line. We're going to try and reflect the image, not the original, but S prime, Q prime, U prime, R prime over this line. What is this line? X equals 2. Okay, I want you to pause it right here and try and figure out where X equals 2 is and draw that line. And whenever you find that line, then flip the figure over. So you'll have 3 squares at the end. The original, the S prime, Q prime, U prime, R prime, and then your last one, which is a reflection of the blue square. And pause it, see if you can figure out where that is. When you're all done, watch the rest and see if you figured it out. All right, let's see. So X equals 2, we've got the origin right here at X equals 0, X equals 1. X equals 2 is right here. And so we want to reflect over that line. So we're going to take our square and we're going to fill in. Now notice that point R prime is already there. So R double prime is not going to move. It's going to be on the same spot. U prime is 1, 2, 3 to the right. So U double prime is going to be 1, 2, 3 to the left on the same spot as the original R. All right, and then S prime is 1 to the right. So S double prime is going to be there. Q prime is 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left will be S double prime. We connect those, we're going to get our last, oh, I used the wrong letter over there. That should have been Q double prime. Okay, so we'll talk about this more when I get back. You've got the rest of the time to work on an assignment where you're not only going to identify reflection, rotation, or translation, but you're going to try and give it as much detail as possible. Like what we did up here, you're going to state what it's reflecting over. You're going to give the translation vector that we talked about from A to D. It was a translation of -4, -7. When we reversed it, we're going to go from that to being +4, +7. Okay, and when you get to rotation, you're going to try and figure out things like how many degrees is the turn, and what is it turning around, and the direction, which would be clockwise or counterclockwise. And we will check that when I get back. Hope you have a great day, and I'll see you on Tuesday.